Think about your day. When was the last time you didn't use your phone? These little slabs of glass and metal are essential. We use them for everything. We stay connected and capture memories. We even control our homes. But have you ever thought about how they're made? It's a journey across continents involving cutting-edge technology. From mines to factories, it's a marvel of modern manufacturing. Join me as we go behind the scenes. Let's explore the fascinating world of phone manufacturing. We often take for granted the complexity of the device we hold in our hands. A smartphone is anything but simple. It's a symphony of technology, a testament to human ingenuity. Within its sleek casing lies a labyrinth of intricate components. Each one plays a crucial role in making the magic happen. Think about it, you've got a powerful computer, a high-definition camera, and a GPS system. And those are just a few of the features packed into this pocket-sized powerhouse. The screen alone is a marvel of engineering. It's made up of millions of pixels that work together to deliver crystal-clear images and vibrant colors. But before we delve into the intricacies of the manufacturing process, let's rewind. We need to go back to the very beginning. Let's unearth the origins of the raw materials that form the building blocks of our digital companions. The journey of a smartphone begins long before it reaches the assembly line. It starts with the raw materials, the fundamental elements that are transformed into this technological marvel. We're talking about metals like copper, gold, and aluminum. These are essential for the phone's circuitry and casing. Then there's lithium, the powerhouse behind your phone's battery. And let's not forget silicon, the unsung hero that forms the heart of the phone's brain, the microprocessor. Sourcing these materials is a global endeavor. Mines and refineries from around the world work tirelessly to extract and process these precious resources. But this is just the beginning. The journey from raw materials to a finished smartphone is a complex ballet of engineering, design, and manufacturing prowess. Join us as we venture further into the heart of the factory, where these raw elements are transformed into the sleek and sophisticated devices we know and love. Our phones are like tiny museums. They hold a collection of elements from every corner of the planet. We're talking about a global treasure hunt, a quest for the raw ingredients that make our digital lives possible. Take copper, for example. It's the unsung hero of electronics. Copper's conductivity makes it perfect for wiring. Chile, the world's copper king, supplies a good chunk of what we need, but it doesn't stop there. From the mines of Peru to the Democratic Republic of Congo, the search for these tech-essential elements is a global endeavor. It's a reminder that our phones are more than just gadgets. They're a product of the Earth itself. From African soil, the cobalt conundrum. Let's talk about cobalt, a metal with a complicated story. It's a key ingredient in the lithium-ion batteries that power our phones. But sourcing cobalt comes with a heavy price tag. The Democratic Republic of Congo holds over half of the world's cobalt reserves, and the mining practices there have raised serious ethical concerns. We're talking about dangerous working conditions, child labor, and environmental damage. It's a stark reminder of the human cost of our tech addiction. As consumers, we have a responsibility to demand ethical sourcing practices. We need to ensure that the raw materials in our phones are obtained responsibly and sustainably. Section 3, lithium's long journey powering up from below. Ever wondered where your phone's battery gets its juice? Lithium, the lightest metal on Earth, is the key. It's a highly reactive element found in salt flats and underground brine reservoirs. And the process of extracting lithium is no walk in the park. It's a complex and energy-intensive process. Think of vast evaporation ponds stretching for miles under the scorching sun. That's how we get lithium. The lithium triangle in South America, Chile, Argentina, and Bolivia holds the lion's share of these precious reserves. But even with these vast resources, the demand for lithium is skyrocketing. Section 4, Silicon Valley's secret sauce, sand to circuits, Silicon Valley. The name itself hints at the crucial element that drives our digital world, silicon. It's the backbone of microchips, the brains behind our smartphones. And guess what? Silicon comes from sand. But not just any sand, we're talking about high-purity silica sand, found in specific regions around the world. This sand undergoes an incredible transformation. It's melted down, purified, and then sliced into thin wafers. These wafers are the canvases upon which intricate circuits are etched, layer by layer. It's a marvel of engineering, a testament to human ingenuity. Blueprints of innovation, designing the digital heart. We've got our raw materials mined and refined. Now, the real magic begins. This is where the artists and engineers step in, the dreamers and the doers. They gather around digital drafting tables, their faces illuminated by the glow of high-resolution screens. They're armed with powerful software, ready to translate imagination into reality. Imagine a digital canvas. On this canvas, lines are drawn, shapes are molded, and ideas take form. This is the birth of a smartphone, the genesis of a digital companion. Every button, every curve, every pixel is meticulously planned. It's a fusion of art and science where aesthetics meet functionality. But it's not just about looks. These digital blueprints dictate everything. They determine the placement of the processor, the arrangement of the antenna, the size of the battery. It's a delicate balancing act, a symphony of components working in perfect harmony. Pixels and prototypes, bringing ideas to life. The digital blueprints come alive in the prototyping phase. This is where the rubber meets the road, where concepts transform into tangible objects. Remember those sleek 3D models on the designer's screen? They're about to make the leap from the digital realm to the physical world. Enter the 3D printer, a modern-day magician. Layer by layer, it extrudes molten plastic, building a physical representation of the digital design. These prototypes are the first physical embodiment of the smartphone, a chance for designers and engineers to hold their creation in their hands. But it's not just about aesthetics. These prototypes are put through the ringer. They're poked, prodded, and tested to ensure that the design is ergonomically sound, that the buttons are in the right place, that the overall feel is just right. From CAD to 3D, shaping the future one layer at a time. Let's talk about CAD, or computer-aided design. This software is the digital sculpting tool of the 21st century. It allows engineers to create incredibly detailed 3D models of the phone's components. It's a powerful simulation platform. Engineers use CAD to test the phone's durability and to optimize its performance before a single physical component is created. Before a smartphone is deemed ready for the masses, it undergoes a battery of tests that would make even the toughest gadget sweat. We're talking about drop tests, where phones are tumbled from various heights to ensure they can survive the inevitable fumbles of everyday life. Then there are the temperature tests, where phones are subjected to extreme heat and cold to mimic the harsh conditions they might encounter in the real world. Think scorching deserts and frigid mountaintops. The goal is to make sure the phone can handle it all. But it's not just about physical resilience. The phone's software is put through its paces as well. Engineers run countless simulations, bombarding the phone with data and pushing its processing power to the limit. They're looking for bugs, glitches, and any vulnerabilities that could compromise the user experience. We've got our raw materials, our designs, our prototypes. Now, let's step inside the real heart of the operation, the factory floor. Imagine a vast, brightly lit space humming with activity. This isn't your grandpa's factory. This is a high-tech ballet of precision and automation where human hands work in concert with robotic arms. Think of it like this. Each phone is on a journey, traveling down a carefully choreographed assembly line. Along the way, it encounters a team of skilled technicians, each with a specific task to perform. It's a symphony of coordinated movements, a testament to human ingenuity and the power of teamwork. At each station, components are added, connections are made, and the phone slowly starts to take shape. Screws are tightened with surgical precision, cables are threaded through impossibly small openings, and circuit boards are slotted into place with the grace of a car dealer in Vegas. The circuit board is the phone's nervous system, a densely packed labyrinth of electronic pathways that carry the signals that make everything work. Assembling these intricate boards is a marvel of miniaturization and precision, a task often entrusted to the nimble fingers of robotic arms. Picture this: a robotic arm guided by lasers and cameras picks up a tiny component, a resistor, a capacitor, a microchip with the delicacy of a surgeon handling a scalpel. The arm then positions the component onto the circuit board, where it's soldered into place with pinpoint accuracy. These robotic arms work tirelessly, repeating the same intricate movements thousands of times per day without a hint of fatigue or error. It's a testament to the power of automation, a glimpse into the future of manufacturing. Section 3. Screen time. Assembling the window to your world. Now let's talk about the screen, the window to our digital lives. The display module is a marvel of engineering in its own right, consisting of multiple layers that work together to deliver those crisp images and vibrant colors we've come to expect. First, the LCD or OLED panel is carefully aligned with the touchscreen layer. These two components are bonded together using a combination of heat and pressure, ensuring a seamless connection between the image source and the touch-sensitive surface. Next, the display module is attached to the phone's body. This is a critical step as it requires precise alignment to ensure that the display sits flush with the phone's bezels and that the touchscreen functionality isn't compromised. Section 4. Camera ready, capturing memories, pixel by pixel. For many of us, our smartphones are our primary cameras, capturing life's precious moments, from birthday parties to epic sunsets. But have you ever stopped to think about the intricate assembly process that goes into creating these pocket-sized photography powerhouses? The camera module, while incredibly small, is a complex assembly of lenses, sensors, and image stabilizers. These components are carefully aligned and assembled, often in a dust-free clean room environment to prevent any contaminants from affecting image quality. Once assembled, the camera module is rigorously tested to ensure that it meets the stringent quality standards required for capturing high-fidelity images and videos. It's a testament to the meticulous engineering that goes into every aspect of smartphone manufacturing. Section 5. Testing. 1, 2, 3. The gauntlet of quality control. Before a phone earns its ticket out of the factory, it faces a gauntlet of tests designed to push it to its limits. This is where the rubber really meets the road, where any manufacturing defects or performance hiccups are ruthlessly exposed. We're talking about drop tests onto hard surfaces, mimicking those heart-stopping moments when your phone takes a tumble. Then there are button-mashing marathons, where automated systems simulate years of frantic texting and game playing to ensure those buttons can take the heat. Of course, no smartphone testing regimen would be complete without a healthy dose of software scrutiny. Engineers unleash a barrage of data, pushing the processor to its limits, testing the responsiveness of the touchscreen, and ensuring the software runs smoothly, even under the most demanding conditions. Trial by fire, putting phones through the ringer. Imagine a phone's worst nightmare: tumbles onto concrete, dunking in the toilet, sweltering heat, freezing cold. These are just a few of the trials a smartphone must endure before it earns its place in your pocket. Welcome to the Quality Assurance Lab, a place where phones face their greatest fears. Here, engineers design tests that are brutal, unforgiving, and absolutely essential. They're not trying to be cruel. They're on a mission to ensure that only the toughest, most reliable phones make it out the factory door. Think of it as a rite of passage, a trial by fire, Only the phones that emerge from these tests unscathed, their screens uncracked, their circuits humming, their software running smoothly, are deemed worthy of joining the ranks of smartphone royalty. Drop and roll testing for Butterfingers and beyond. Let's face it, we've all been there. That heart-stopping moment when your phone slips from your grasp, tumbling towards the unforgiving ground in slow motion. It's a universal experience, a shared fear among smartphone users everywhere. That's where the drop test comes in. It's the ultimate test of a phone's structural integrity, a simulation of those all-too-common accidental drops. Engineers rig up contraptions that mimic various real-world scenarios, dropping phones from different heights and at different angles. They analyze the results, checking for cracks in the screen, dents in the casing, and any signs of internal damage. The goal is to ensure that the phone can withstand the bumps and bruises of everyday life, even if it means sacrificing a few prototypes along the way. Waterworks. Making a splash or not? Remember that sinking feeling you get when your phone takes an unexpected dip in the pool, the toilet, or even worse, a puddle of questionable origin? Water and electronics are not the best of friends, which is why water resistance is a crucial feature for any self-respecting smartphone. To test a phone's ability to handle a little H2O, engineers devise a series of increasingly demanding water challenges. It starts with a light drizzle, simulating a phone caught in a sudden downpour. Then comes the dunk tank, where phones are submerged in water for a specific amount of time to test their waterproofing seals. And for the truly adventurous phones, there's the pressure chamber, where they're subjected to the crushing depths of simulated ocean dives. Only the phones that emerge from these watery trials, dry and fully functional, earn those coveted IP ratings that signify their aquatic prowess. Section 4, Software Stress Test, pushing pixels to the limit. While physical durability is crucial, a smartphone is only as good as the software that powers it. That's why software testing is just as rigorous and unforgiving as the physical trials. Engineers unleash a barrage of digital torture tests, pushing the phone's software to its absolute limits. Imagine thousands of apps launching simultaneously, a torrent of data flooding the processor, the battery draining at warp speed. These simulated scenarios are designed to stress the phone's operating system, to uncover any hidden bugs, glitches, or performance bottlenecks. They monitor everything: processing speed, battery life, network connectivity, app responsiveness, ensuring that the phone delivers a smooth and enjoyable user experience even under the most demanding conditions. After all, the phone that can't handle a little multitasking is hardly worthy of the smart designation. From factory floor to storefront, our phone has run the gauntlet. It's been poked, prodded, dropped, and dunked, and it's emerged victorious. This marvel of engineering is about to embark on a new adventure, ready to embark on a global relay race to your hands. The global relay race, your phone's journey across continents. Hold on tight, because this is where things get really interesting. Remember those raw materials sourced from every corner of the globe? Now the finished product retraces those steps, crisscrossing continents through global trade. Imagine cargo ships laden with containers full of smartphones. Picture jumbo jets, their cargo holds humming with millions of tiny circuits. It's a logistical ballet of epic proportions, essential to getting that shiny new phone into your hands. Section 3. The grand unboxing, a technological marvel in your hands. After weeks of travel, countless miles logged, and a few thousand bumps along the way, our phone has finally reached its destination, the store shelf. There it sits, patiently waiting for you, its future owner, to pluck it from its cardboard cradle and unleash its digital potential. The moment has arrived. You carefully lift the lid of the box, peeling back the protective layers like an archaeologist uncovering a priceless artifact. The anticipation builds as you catch your first glimpse of the sleek, gleaming surface of your new smartphone. Your fingers dance across the smooth glass, exploring the contours of its design, marveling at the culmination of engineering and craftsmanship held within your grasp. With a tap and a swipe, you power it on, breathing life into its intricate circuitry, ready to embark on a world of possibilities.